Hi, it's Margaret Maloney. I thought we would take some time together and revisit the network diagram. You know, for many of us, creating the network diagram can be very complicated and daunting, especially the first few times through it. You know, there are a few of you who can look at a list of activities along with their estimates, and you can see the schedule right in your head. You get the picture right away. But most of us need to practice creating a network diagram multiple times, more than one, more than two, more than once, more than twice. With this thought in mind, let's walk through it again. And be sure to pause this video as many times as you want and watch parts of it over as many times as you want, because it's for you. So this is about you and your learning. Please don't cheat yourself. What you have is you've got, see this area here, I'm going to highlight it here for a minute. This is work. Now, this is a project for building a stage, allegedly, because it's simplified for us, so I'm sure that building a stage is more than this. And what we have is the activities with just their numbers, their IDs. We have a description of them. For example, activity 1 is hiring workers. And then we have a duration. And I'm going to say days, even if that's crazy. Maybe it's a really big stage. But I'm just going to use days because it's simple to talk that way for me. And then what we have over here is predecessor. What comes before? What comes before? And you remember that if an activity has no predecessor, which is true of items 1 and 2, then they are the first pieces of work that can occur, right? So keep that thought in mind. Over here, let me highlight this, we have a legend. And that legend is showing us these rectangles that we're using to map out different fields, because we are going to be like computer project scheduling software. We're going to do some calculations. And the calculations that you and I are doing are what your scheduling software does actually do for us. So we have the rectangles divided up with a little legend. See in this top corner here, top left-hand corner, it's ES. That means early start. What is the soonest that this piece of work can begin? Here we have just an identifier, which is the activity number. Here we have EF. EF like Frank, early finish. How soon can the activity finish? Here we have something called float. You will also hear people use the word slack. Float and slack are used interchangeably. And then we have LS, or late start. What is the latest that this activity can start? I know that sounds weird, but as we go through this, it will hopefully begin to make more sense. Duration, which just comes from the table over here. How long is it going to take? Just like the activity number came from the table over here. And LF, late, again, LF like Frank, or finish, which is what it is, right? Late finish. What is the latest this can finish? And we mean without delaying the project, or without delaying the work that happens after it as well. Okay? Now, what we do to find out the path of the project is we do what's called a forward pass, and we do what's called a backward pass. And the forward pass, involves you and I going through this network diagram down here from left to right, and that is the forward pass. And we go through each activity, and we're going to calculate on a forward pass what is the early start and what is the early finish for each piece of work. When we do a backward pass, then we are going from right to left, so we're going from the end to the beginning, and we are calculating the late start and the late finish. So we need the forward pass and then the backward pass. When we have finished both, then we can calculate the float. So where did this diagram come from? That just this here comes from this up here. So remember when I said if an activity has no predecessor, it means it could be the first work. So activity 1 and 2 neither have predecessors. So when we draw our network diagram, we know that 1 and 2 can both happen at the start of the project. And that also means since they don't have a predecessor, they can both happen in parallel. So that's how we draw them. Now, activity 3 has predecessor of 1 and 2. So activity 3
cannot start until 1 and 2 finish. And by the way, when we do draw these, we do assume a finish-start relationship. So 1 must finish before 3 can start, 2 must finish before 3 can start. Now, activities 4, 5, and 6, look at them. 3 is the predecessor to all of them. And since they have no other predecessor, we know that all other things being equal, those 3 activities, installing the lights, installing the sounds, and installing the seats, can all happen at the same time. They just have to wait for 3 to finish. Then when we get to cleaning this stage, which is the last thing we do, cleaning this stage cannot be accomplished until we finish 4, 5, and 6. That's how we got this flow here, this network diagram. That's how we came up with the way in which things are ordered. I do recommend that you might practice that as well, and that you take this table here and you give yourself some time and you practice drawing this diagram down here without looking at it. We have our network laid out. We have parts of our legend for each one filled in, right? Because we have the activity and the duration filled in on each item. And by the way, I always recommend that. Do the easy stuff first. So go in, once you have the work mapped out, once you have this, structure drawn, go into each one and fill in the activity and the duration for each one, because it helps you, because you're going to use it in the calculation. Now, let's begin our forward pass. Okay. On the forward pass, the early start, and we're using the approach where we start with day 1. The early start is always 1. We start on day 1. Okay? So that's easy for the first activity or activities. To get the early finish, we take the early start plus the duration minus 1. So let's fill that in, and then we'll come back and talk about that for a minute. So early finish goes here. It's the early start, which is 1, plus the duration, which is 20, which is, now that makes that 21 minus 1, which makes it 20. Okay, that goes there. Over here, 1 plus 10 minus 1 gives me 10, right? Okay. Now, why do we subtract out the 1? Because this 1, this stray 1 that follows us through the forward pass and the backward pass, this is the thing that usually confuses most of us. Think of it this way. We're going to start the work at the beginning of the day, and when we finish at the end of the last day. Okay, now I'm going to use an easy example now, because I'm going to run out of fingers otherwise. And I often will do this on my fingers, and if I'm standing in front of a group of people, I will actually count it out on my fingers. But think about this. Let's say we had a piece of work, and it was 5 days. We started on the first day. Do we call that 6 days? In other words, do we take day 1 and add in the duration and say that we finish on the 6th day? Now think about it. If it's 5 days, and I really finish it at the end of the last day, here's how it works. I work 1 day, I work 2 days, I work the 3rd day, I work the 4th day, and I work the 5th day. At the end of the 5th day, I'm done. So therefore, my early finish is 5. Okay? That's why we're netting out for the 1. Okay, so now with activities 1 and 2 set up, we have to look at activity 3. Now, activity 3, how do I get the early start for a successor? So now we want to look at successor, because 3 is the successor to 1 and 2. Okay, well, here is the formula, but, hang on, we have a little typo there. Well, here's the formula. But what if an activity has more than one predecessor? And that happens to be true right off the bat. We have to use this rule here, the what if an activity has more than one predecessor rule. We use the highest early finish of the predecessor, or the predecessors, the highest early finish. That means we're going to use the 20, because 20 is greater than 10. See, that's not easy. I mean, that's not hard. Sorry, right? That's not difficult. We use the 20. Now, what's the formula? The formula is that predecessor plus 1. So I take 20 and I add in 1. So I start activity 3 on day 21. And that makes sense because activity 1 ended at the end of day 20. So we come back in the next morning and we start off activity 3. Now, why would I take the predecessor, the highest early finish? Why would I take the highest number? You know this, of course. Because if I have to wait for 2 things to finish, both these items have to finish before I can start 3, I cannot start until the last one finishes. There you go. So that's that trick. Now, to get the early finish, I'm really just taking the early start plus the duration minus 1, right? So 21 plus 20 is 41, minus 1 is 40. Okay, now, activity 4, 5, and 6, their early starts, they all have one predecessor, which is 3. Yay, so this one's more simple. Yay, happy about that. And they all inherit their early start from the predecessor plus 1. So that's this formula right here. Okay, so that means they all get their early starts are equal to the early finish of the predecessor, which is 40, plus 1, which means 41. Again, the same thing because the work ended at the end of day 40, so we pick up again at the beginning of day 41. Okay? Now, to do the early finish, it's our same old thing again. We take the early start, right? Here's our formula again, plus the duration, minus 1. So 41 plus 5 is 46, minus 1 is 45. 41 plus 10 is 51, minus 1 is 50. 41 plus 7 is 48, minus 1 is 47, and there we go. Now we're at the very last activity. And again, I have to make a choice because there's more than one predecessor. So again, I use the highest early finish because if it must wait for everything, all 3 of those activities to finish before it can start, it cannot start until the last one begins. So that means I use the early finish of 50 because that's the highest one, right? And now it's 50 plus 1. It's 51. And now I apply my early finish calculation, which is becoming easier for you and I. And that's just the early start plus the duration minus 1. So 51 plus 2 is 53, minus 1 is 52. Yay. Now that is our forward pass, so step back. Now we're going to do the backward pass. And again, the backward pass means you go from the end to the beginning, or from right to left. And we're going to figure out the late start and the late finish. Now, the late start of the last activity, which is right here, this is easy. It's the same number as the early finish. I said late start, didn't I? Pardon me, late finish. The late finish of the last activity is easy because the late finish is the same as the early finish. We either finish or we don't. There's not 2 finish dates. So that's nice. That's 52. Now, how do I get my late start, which should go right here? My late start is the late finish minus the duration plus 1. So I'm just working backwards. So 52 minus 2 is 50, plus 1 is 51. Whew, awesome. Now, I have my late finishes here. And my late finishes all are going to be from the late start. They all get inherited from the late start of the successor. Okay? And that means that, okay, late finish is equal to the late start minus 1. Okay, so 51 minus 1 is 50. So all of these have a late finish of 50, right? Now I have to figure out the late starts for all of them, and it's the same thing again, which is the late start is the late finish minus the duration plus 1. So 50 minus 5 plus 1. So 50 minus 5 is 45, plus 1 is 46, right? Now, here we go. 50 minus 10 plus 1. 50 minus 10 is 40, plus 1 is 41. And now I have 50 minus 7, 43. I'm getting dingy here. And that's 40, minus 1 is 42. So let's step back and make sure that's correct. Okay, so we have late finishes all came from the predecessor, the late start of this one. That makes sense. Now, our late start, again, is equal to late finish minus duration plus 1. So that's how we got our 50 minus 5 plus 1 is 46. My 50 minus 10 plus 1 is 41. And my 50 minus 7 plus 1. I have a hard time doing it sometimes too, you guys. I apologize for that. Let's look at this last one. I think this last one is wrong. 50 minus 7 is 43, plus 1 is 44. That's where I'm off. Yep, there we go. Okay, thank you for being patient with me. Now, we have an activity that has more than one successor. And that's this guy right here. So activity 3 has 3 successors. And that means we have to make a choice in terms of what late start to use to work backwards, because there's 3 choices. I could use 46, 41, or 44. So what do you think I should use? When we are doing the backward pass, we use the lowest number. We use the lowest number. So let's do that and perform the calculation. What's the lowest late start over here? It's the 41, right? So now I get my late finish here is equal to 41 minus 1. Phew, I can do that one. It's 40. And now to get my late finish, again, my late start, I apologize that I keep messing those up. To get my late start, I now take 40, which is the late finish, minus the duration, which is 20, plus 1. So that gives me 21. Phew. Okay, now back here, I have only one late start to move forward to make it into the late finish, right? So this becomes 20, and this becomes 20. Because remember, the formula for late finish is to take the late start and subtract 1. And now, thank goodness, we're on the very last 2 where we're working backwards, and we're figuring out our late starts. And so we take that late finish, subtract out the duration, and add in 1. So 20 minus 20 is 0, plus 1 is 1. And 20 minus 10 is 10, plus 1 is 11. You see the picture that's being painted here? At first, it may not have made sense that we could have a different start and a different finish. Like, why wouldn't we just start and finish all at the same time? But what this picture is showing us, what we've just figured out, is that there are some times where there are pieces of work, activities, that can be delayed, and it won't delay the end of the project. So if we're calling these days, and we're saying right now this is day 52, we don't want anything to happen to make it go to day 53. And so what we have is work that has to happen exactly on certain days in order to make it to day 52. That's the critical path. That is the critical path. The definition for the critical path is weird because it's that definition, which is the critical path is the most amount of time it takes to get you through the network, and therefore it is the minimum amount of time it will take to finish the project. When we look at some of the pieces of work here, we can see that there's a difference between some of their late starts and early starts, and late finishes and early finishes. And when that happens, we have a value for floats. And so what we want to do next is go through and calculate float. And float is going to go in here, this section. And float, you can use 2 different calculations, because if I've done this correctly, and I hopefully corrected my errors that I had earlier, I'm going to get the same number. So float is either late start minus early start or late finish minus early finish. Okay, now let's step back. Your critical path is the tasks or activities that have 0 float. Those are the items that have to absolutely finish per plan or we're going to be late. And now you can see here, if you've been wondering why some of this was highlighted, that's because I had left some of the highlighting in. The items that have float are actually shaded in yellow on here. And so if you just now go back to the beginning and we look at these first 2 activities, activity 1 and 2, they both could start at the beginning, but one took 20 days and one took 10 days. Right away, you probably knew that that meant that the second activity, which took 10 days, which was buying supplies, probably could wait a few days, because what's really driving the schedule was the 20 days we needed to take to hire the workers. Then, since activity 3 is next, and it is the only next thing, it makes sense that that's the critical path. Then when we get to installing the lights, the sound, and the seats, what drives the completion of the project is whichever one of those items is going to take the longest amount of time. Which one is going to take the longest? Installing the sound. So installing the sound must go as scheduled, and installing the lights has 5 days of float, and installing the seats has 3 days of float. Now the last activity has no float, and that makes sense as well. If it's the very last thing that happens and it's the only item that happens at the end, it can't have float. It needs to finish in order for us to finish up on day 52. So that's our forward pass, our backward pass, our floats, our critical path, and that's our day 1 approach using.
Phew, all right. Great job. Thank you for sticking with it. And remember, for most of us, the network diagram takes practice, practice, practice. You know, it's worth it though, because when you understand the critical path and where you have float and what is driving your project schedule, you have mastered one of our critical project management concepts. So thanks for hanging in there. And you know what I say, bye for now.